Welcome. Today we're diving into the fascinating world of large language models, or LLMs, and exploring how they're trained. At the heart of every powerful AI language model lies a vast collection of data. But how is this data gathered and why does it matter so much? In this video, we'll break down the main data collection methods used for training LLMs, discuss their strengths and challenges, and see how each method shapes the capabilities of these advanced models. Let's start by understanding why data is the backbone of LLM training. Data is the fuel that powers LLMs. The quality, diversity, and quantity of data directly influence how well a model understands language, context, and nuance. Without robust data, even the most sophisticated algorithms can't perform at their best. That's why researchers invest so much effort into collecting and curating massive datasets. In the next scenes, we'll explore the various sources and methods used to gather this essential data. One of the most common methods for collecting data is web scraping. This involves automatically extracting text from websites, blogs, forums, and news articles. Web scraping allows researchers to gather a wide variety of language samples, covering different topics, writing styles, and perspectives. However, this method also requires careful filtering to avoid low quality or irrelevant content. Let's look at how web scraping works in practice and why it's so popular for LLM training. Another key source of data is public datasets. These are collections of text that have been made available by organizations, researchers, or governments. Examples include Wikipedia, Common Crawl, and Project Gutenberg. Public datasets are valuable because they are often well organized and cover a broad range of subjects. They provide a solid foundation for training LLMs, ensuring the models learn from reliable and diverse sources. In addition to public datasets, many organizations use licensed data sources. These are collections of text that require permission or payment to access, such as proprietary books, academic journals, or news archives. Licensed data often provides high-quality, specialized content that isn't freely available online. By incorporating licensed data, LLMs can gain deeper knowledge in specific domains and improve their overall accuracy. User-generated content, such as social media posts, forum discussions, and product reviews, is another rich source of data. This type of content reflects real-world language use, slang, and emerging trends. However, it also comes with challenges like inconsistent quality and potential privacy concerns. Careful curation is needed to ensure that only appropriate and useful data is included in the training process. Books, both fiction and nonfiction, are a treasure trove for LLM training. They offer well-structured, high-quality language and cover a wide range of genres and topics. By including books in the training data, models can learn complex sentence structures, storytelling techniques, and specialized vocabulary. This helps LLMs generate more coherent and creative responses. Academic papers provide a wealth of specialized knowledge and technical language. By training on academic literature, LLMs can better understand scientific concepts, research methodologies, and domain-specific terminology. This is especially important for applications that require accurate and reliable information, such as medical or legal AI tools. News articles are another important data source. They provide up-to-date information on current events, politics, science, and culture. Including news content helps LLMs stay relevant and informed about the world. However, it's crucial to balance sources to avoid bias and ensure a fair representation of different viewpoints. Government data, such as public records, legal documents, and policy papers, offers authoritative and factual information. This type of data is especially useful for training models that need to provide accurate, trustworthy answers in areas like law, governance, and public services. Using government data helps ensure that LLMs are grounded in reliable sources. To make LLMs more versatile, data is collected in multiple languages. Multilingual data allows models to understand and generate text in various languages, making them useful for global users. This approach also helps the model learn about different cultures, idioms, and linguistic nuances, broadening its capabilities and reach. Conversational data such as chat logs and transcripts is essential for training LLMs to interact naturally with users. This data helps models learn dialogue structure, turn-taking, and context management. By including real conversations, LLMs become better at understanding questions and providing relevant, human-like responses. Some LLMs are trained using audio and speech data, especially when they need to handle spoken language. Transcribed audio, podcasts, and interviews provide examples of natural speech patterns, accents, and intonation. This helps models better understand spoken queries and generate more accurate responses in voice-based applications. For models that handle both text and images, image-text pair data is crucial. This involves collecting images along with their descriptions or captions. Such data enables LLMs to understand the relationship between visual and textual information, paving the way for advanced applications like image captioning and visual question answering. Crowdsourcing is a method where data is collected from a large group of people, often through online platforms. Participants might be asked to label text, translate sentences, or provide feedback. Crowdsourced data helps improve model accuracy, especially in areas where expert data is limited or where diverse perspectives are needed. Synthetic data is artificially created rather than collected from real-world sources. This can involve generating new text using algorithms or simulating conversations. Synthetic data is useful for augmenting datasets, balancing classes, or creating examples for rare scenarios. It helps fill gaps where real data is scarce or sensitive. Raw data often needs to be annotated before it can be used for training. Annotation involves labeling text with information such as sentiment, topic, or named entities. This process helps models learn to recognize patterns and make accurate predictions. Annotation can be done manually or with the help of automated tools. For training, data must be cleaned to remove errors, duplicates, and irrelevant content. Data cleaning ensures that the model learns from high-quality, accurate information. This step is crucial for preventing biases and improving the overall performance of the LLM. Let's see how data cleaning is performed. Filtering is the process of selecting only the most relevant and useful data for training. This might involve removing spam, offensive content, or low-quality text. Effective filtering helps models focus on learning from the best examples, leading to more accurate and reliable outputs. Deduplication is about removing duplicate entries from the dataset. Repeated data can skew the model's learning and lead to overfitting. By ensuring each example is unique, deduplication helps create a more balanced and effective training set. Balancing the dataset means ensuring that all topics, languages, or classes are fairly represented. If one category dominates, the model might become biased. Data balancing techniques help create a more equitable and comprehensive training set, leading to fairer and more accurate models. Augmentation involves expanding the dataset by creating new examples from existing data. This can include paraphrasing sentences, translating text, or generating synthetic samples. Data augmentation helps models generalize better and perform well on a wider range of inputs. Ethics play a crucial role in data collection. It's important to respect privacy, obtain proper consent, and avoid using sensitive or harmful content. Ethical data practices ensure that LLMs are trained responsibly and do not perpetuate biases or cause harm. Legal issues are another important aspect of data collection. Organizations must comply with copyright laws, data protection regulations, and licensing agreements. Failing to follow legal guidelines can lead to serious consequences and undermine the integrity of the model. Bias can creep into datasets through overrepresentation or underrepresentation of certain groups or viewpoints. Recognizing and addressing bias is essential for building fair and trustworthy LLMs. Techniques like data balancing and careful curation help minimize bias and promote inclusivity. Protecting user privacy is a top priority in data collection. Personal information must be anonymized or excluded to prevent misuse. Strict privacy measures help build trust and ensure that LLMs are trained on data that respects individual rights. Data security involves protecting datasets from unauthorized access, leaks, or tampering. Secure storage, encryption, and access controls are essential for safeguarding sensitive information and maintaining the integrity of the training process. Knowing where data comes from is called data provenance. Tracking provenance helps ensure that datasets are reliable, legal, and ethically sourced. It also makes it easier to audit and improve the training process over time. Open data initiatives encourage the sharing of datasets for research and development. By making data freely available, these initiatives foster innovation and collaboration in the AI community. Open data helps level the playing field and accelerates progress in LLM training. Diversity in data ensures that LLMs can understand and represent a wide range of perspectives, cultures, and languages. Diverse datasets help models avoid narrow viewpoints and become more inclusive, making them useful for a broader audience. LLMs are constantly evolving, and so is their data. Continuous data collection means regularly updating datasets with new information, trends, and language patterns. This keeps models current and ensures they remain effective as language and society change. Human-in-the-loop approaches involve people in the data collection and training process. Humans can review, correct, and improve data, ensuring higher quality and reducing errors. This collaborative method combines the strengths of both humans and machines. Feedback loops allow models to learn from user interactions. By analyzing how users respond to model outputs, researchers can identify weaknesses and update the training data accordingly. This process helps LLMs become more accurate and user-friendly over time. Sampling techniques are used to select a representative subset of data for training. Random sampling, stratified sampling, and other methods help ensure that the model learns from a balanced and diverse set of examples, improving its generalization abilities. For specialized applications, domain-specific data is collected. This might include medical records, legal documents, or technical manuals. Training on domain-specific data helps LLMs become experts in particular fields, providing more accurate and relevant answers. Temporal data collection involves gathering data over time to capture trends, changes, and evolving language use. This approach helps LLMs stay up to date and understand how language shifts in response to cultural or technological changes. Quality assurance processes are put in place to verify the accuracy and consistency of training data. This can involve automated checks, manual reviews, and validation against trusted sources. High-quality data leads to better performing and more trustworthy LLMs. Storing large datasets securely and efficiently is a challenge. Organizations use advanced storage solutions such as cloud databases and distributed systems to manage and protect their data. Reliable storage is essential for smooth training and future updates. Access control mechanisms restrict who can view or modify training data. By setting permissions and monitoring usage, organizations protect sensitive information and prevent unauthorized changes. Proper access control is vital for data security and compliance. Data versioning tracks changes to datasets over time. This allows researchers to compare different versions, roll back to previous states, and ensure reproducibility. Versioning is especially important for large, collaborative projects where data evolves frequently. Comprehensive documentation describes how data was collected, processed, and used. Good documentation helps researchers understand the dataset's strengths and limitations, making it easier to improve and maintain over time. Clear data sharing policies outline who can access, use, and distribute datasets. These policies help protect intellectual property, ensure compliance, and foster responsible collaboration within the AI community. Managing the entire lifecycle of data from collection to deletion is essential for effective LLM training. Lifecycle management ensures that data remains relevant, secure, and compliant throughout its use, supporting long-term model success. As technology evolves, new data sources are emerging, such as IoT devices, wearable tech, and interactive media. Incorporating these sources can further enhance LLM capabilities, making them more adaptable and responsive to future needs. Summary: data collection is a complex and vital process in training LLMs. From web scraping to ethical considerations, each method plays a unique role in shaping model performance. As AI continues to advance, new data sources and improved practices will drive even greater capabilities. By understanding and refining data collection methods, we can build smarter, fairer, and more powerful language models for the future.